This is section 5.7. In this section, our video is really just going to be one long example. And we're going to talk about how to solve these equations relating to circuits. So a series RLC circuit has a voltage source given by E of t is equal to sine of 10t volts, a resistor of 0.01 ohms, an inductor of 0.002 henries, and a capacitor of 3 farads. If the initial charge and the initial current are both 0, determine the current in the circuit for t greater than 0. So let's look what we've got here. L, the reason it's called an RLC circuit, you'll see here, L is our 0.002 henries, R is our 0.01 ohms, and C is our 3 farads. E of t is equal to sine of 10t volts. Now we're going to use a number of laws and equations, and note that for the final exam, it's not going to be about memorizing these equations. You'll be provided with the equations you need. What will be necessary is to know how to use them and how to reach a solution. So here we have Kirchhoff's current law. The same current I passes through each circuit element. So the current through the capacitor equals the instantaneous rate of change of its charge Q. So we have the equation I is equal to dq dt. The voltage drops across the capacitor, the resistor, and the inductor are expressed as follows. E sub c is Q over C, E sub R is R times I, and E sub L is L times di dt. Therefore, Kirchhoff's voltage law, which implies that ER plus EL plus EC is equal to E, can be expressed as such. So again, memorizing these laws and equations, not the point. It's going to be, if I provide you with all of this information, will you be able to do everything from here on out? Are you going to be able to answer the problem? So we will most often be interested in calculating the current I, and that's what we're going to be interested in here too. So we have I in a couple places here. We have di dt, we have an I here. We know that L, R, and C are all constants, so we don't have to view them as variables. And we've even been given what E of t is equal to. But this Q is interesting. What are we going to do about that Q? Well, we've been given this interesting equation that I is equal to dq dt. So if we want to solve this equation with respect to I, let's take the derivative of everything with respect to t. So we get dE dt here. dq dt is just going to be replaced with I for us, so that's nice. I will become di dt, and di dt will become the second derivative of I with respect to t. Now, dE dt, we have to actually take that derivative ourselves. We were given that E is equal to sine of 10t, so that means the dE dt, the derivative with respect to t, is just 10 cos 10t. We can plug in our L, R, and C values. I've drawn this line connecting this derivative here, but I shifted the order of things, so that is actually that I there. So now this is taking on a form that we're familiar with, where we have something times the second derivative plus something times the first derivative plus something times I, with a function of t on the left. So let's get rid of all these decimals by multiplying by 10,000. Or maybe we're only multiplying by 1,000. Yeah, just 1,000. That'll get us out. And then we can actually divide by 2, because that will give us a leading 1 in front of the I prime prime term. So we now have our auxiliary equation as r squared plus 5r plus 500 over 3 is equal to 0. So let's find our solutions. we get that r is approximately equal to -5/2 plus 25.33i and -5/2 minus 25.33i. You'll notice in these real world problems, it's fine to round to a few digits and not get very exact because we need to know approximately what the answer is. So our homogeneous solution is that I is approximately equal to C1 times e to the -5/2t times cos 25.33t plus C2 e to the -5/2t sine 25.33t. To find a particular solution, we use the method of undetermined coefficients. So if we'll scroll back up for a moment, we see that on the left side of this equation, we have something times cos of something. Something times cos of something. So that gives us the general solution, a cos 10t plus b sine 10t. And we take a couple derivatives. Don't forget your chain rule. So we're actually up to 100 on the outside as a factor here. And we're going to set 5,000 cos 10t equal to -100a cos 10t minus 100b sine 10t minus 50a sine 10t plus 50b cos 10t. Where are all these numbers coming from? Well, we have I double prime minus 5 I prime. That's this and this. Sorry, that's plus 5i prime because that negative is the same sign as that. And that positive is the same sign as that. Plus 500/3i. And scrolling up, there's the equation right there. So let's break it into sines and coses. We have 0 sine t here. So we're going to have one equation that is set equal to 0. That's everything multiplied by the sine. And one equation that is equal to 5,000. That's everything that is multiplied by cos. Now we solve this system of equations. We get what b is equal to, we plug it in for b here. We get that a is 60,000 over 1,250. Which is just 48. That simplifies nicely. We plug 48 in as a here, and we get that b is 36. So our particular solution is 48 cos 10t plus 36 sine t, and we add that to our general solution. So now all that's required is to solve for C1 and C2 from the general solution. So we will need the values I of 0 and I prime of 0. Well, we were given that I of 0 is equal to Q of 0 is equal to 0. The initial current was 0. That was stated. So 0 is equal to 48 plus C1. Well, where's 48 plus C1 coming from? When you plug in t equals 0 into these signs, they just disappear. So all that's going to remain is 48 times 1 plus C1 times 1. So we get that C1 is equal to -48. But now what about I prime? Well, let's go back and look at our equation. There is actually an I prime in here. So I prime of 0, we're going to plug in for I prime. So we have to plug in I of 0 as well, and we plug in Q of 0. And sine 10 times 0. So we're just plugging in 0 for all these t's. So we get 0 on the left, of course. Sine of 0 is 0. I of 0, well, we just noted that I of 0 is equal to 0 because that's provided in the question. So that's going to disappear as well. And what about this Q over 3 of 0? Well, scroll up again. Q of 0 is also equal to 0. So All of this stuff is going to fall off except for 0.002 di dt of 0, but it's equal to 0. So I prime of 0 is equal to 0. So we're going to plug that in to the derivative. So for this derivative, all the signs, when you plug in 0, they just disappear because you're just multiplying by 0. The coses, they all become 1. So we're left with 360 minus 5 over 2 C1 plus 25.33 C2. That's because these e to the power of zeros, they also become 1. Now we know C1 is already equal to negative 48, so we can substitute that. We get that 25.33 C2 is equal to negative 480, and that gives us that roughly negative 18.95 is C2. So we get that the equation for our current, I, is approximately 48 cos of 10t plus 36 sine of 10t minus 48 e to the negative 5 over 2t cos 25.33t minus 18.95 e to the negative 5 over 2t sine 25.33t.